Speed and velocity. Speed. The rate of distance covered with time is called speed. Then, first, it is a scalar quantity have symbol shown in this video. Second, dimension m0 l1 t1 unit meter per second, it is a SI unit. Centimeter per second, it is a CGS unit. Type of speed. First, uniform speed. When a particle cover equal distance in an equal interval of time, no matter how small the interval are, then it is said to be moving with a uniform speed. In a given illustration, motorcyclists travel equal distance equals to 5 meter in each second. So we can say that particle is moved with uniform speed of 5 meter per second. Then a figure 2.4 is seen a bike rider ride a bike at their time is given in a graphical portion and uniform speed also given. Then non-uniform uh, variable speed. In a non-uniform speed, particle cover unequal distance in equal interval time. In given illustration, motorcyclists travel 5 meter in first second, 8 meter in a second, 8 meter in a second, 10 meter in a third second, 4 meter in a fourth second, etc. Therefore, its speed is different from every time interval of 1 second. This means particle is moving with a variable speed. Distance were given and time is variable and variable speed. Then average speed. The average speed of a particle for a given interval of time, it is defined as the ratio of the total distance traveled to the time taken. Average speed equals to total distance traveled by time taken. Then speed. Average speed equals to total s2 minus s1 by t2 minus t1, that is delta s by delta t. Time average speed. Time average speed when particle moving with a different uniform v1 v2 v3 etc in a different time interval t1 t2 t3 etc respectively, with average speed over the total time to journey is given. Average speed equals to total distance covered upon total time elapsed. Then it equals to t1 plus t2 plus t3 and up to continue, divided by t1 plus t2 plus t3 etc. equal to v1 t1 plus v2 t2 plus v3 t3 divided by t1 plus t2 plus t3. Distance average speed when a particle describes different distance t1 t2 t3 with different time interval t1 t2 t3 with speed v1 v2 v3 respectively, then the speed of a particle average over the total distance can be given. Average total distance covered by total time elapsed equals to d1 plus d2 plus d3 divided by t1 plus t2 plus t3, d1 plus d2 plus d3 divided by d1, and these format are given. So read as. Then if speed is continuously changed with the time, then average distance average speed equals to integration vdt upon integration dt. Then instantaneous speed, it is a speed of a particle at a particular instant of time When we say speed, it is usually mean instantaneous speed. The instantaneous speed is the average speed of infinitesimally small time interval, that is delta t is equal to 0. Thus instantaneous speed v equals to limit delta t in a limit form, delta t equals to 0. Delta s by delta t equals to ds by dt. Then velocity, the rate of change of position, that is rate of displacement with time, is called velocity. First, it is vector quantity have symbol were given. Then dimension m0 l1 t inverse, unit meter per second in SI, centimeter per second in CGS. Type of velocity, uniform velocity. A particle is said to be have uniform velocity if managed as well as direction of its velocity remains same, and this is possible only when the particle moves in a same straight line without reversing its direction with a constant speed. B. Non-uniform velocity. A particle is said to have non-uniform velocity if either magnitude or direction of velocity change or both of them change. Then average velocity is defined as the ratio of displacement to time taken by the body. Then average velocity equals to displacement upon time taken. Av- this, average velocity equals to delta r vector by delta t. Then instantaneous velocity. Instantaneous velocity is defined as a rate of change of position vector of particles with time at a certain instant of time. Instantaneous velocity in a limit equals to, in a limit form, delta t is equals to 0 delta resultant vector upon delta t equals to d resultant vector upon dt. If a body starting from a starting from rest at a constant rate, this point is not given in this PDF, so listen carefully. If a body starting from rest accelerated as at a constant rate alpha for a certain time and then retard at a constant rate beta and come to rest after t seconds from starting point, then the maximum velocity of the body is alpha beta t upon alpha plus beta, and b, distance covered by body is alpha beta t square upon twice alpha plus twice beta. Then comparison between instantaneous speed and instantaneous velocity. Instantaneous velocity is always tangential to the path followed by the particle. When a stone is thrown from point O, then at a point of a projectile, the instantaneous velocity is v1 at a point A, the instantaneous velocity of v2. Similarly, at point B and C, v3 and v4 respectively. Direction of this velocity can be found out by drawing tangent on a trajectory at a given point B. A particle may have constant instantaneous velocity but variable instantaneous velocity. Example, when a particle is this point will be revised at next video.